I'm Michele. I'm a front-end developer at Whiteplan. I'm a member of WebDevs, and if you like React, JavaScript, and CSS, follow me on Twitter. Most important, I've got the CSS and JS skill on LinkedIn, so you should trust everything I say this evening. A lot of people, like 20 people, crazy people, endorse me for that. I don't know why. 1 year ago, more or less, I had to start a new project, and a lot of people were talking about writing CSS in JavaScript, so I wanted to try that technique. So I created this repo where I basically try all the libraries to deal with CSS in JavaScript in general. Most of them are related to React, others are not. And when I started, there were only 5 libraries. Now, today, we have 32 different techniques to use CSS in JavaScript, and that's the reason why we love open source. And I couldn't find the right one yet, because I guess there is not the right one, but it's super exciting because most of them are solving the problem in a very, very smart way. So maybe you can find the right one for your project. There is no like the right one in the absolute way. When you approach writing CSS in JavaScript, you should have the right mindset, because if you start saying, okay, I'm okay with Sass, I don't want to learn anything new, it's not going to work. You have to give it 5 minutes to try it before you say it's wrong, and you have to be prepared to unlearn everything, because it's something you have to do if you want to write CSS in JavaScript. But why? If you write CSS in JavaScript, you have to unlearn what you learned in the past 15 years, because the way we write web application today is completely different from the way we were used to write web application. We used to have one HTML file, one CSS file, one JavaScript file, but while now we write our application as a mix of components, small components, atomic components. So writing the CSS in the same language you write the logic could make sense. Let's see. So before going into the topic, it's important to understand why people are trying to find new ways to write CSS. Because CSS has some problems. Well, we all know. This is a slide from Visual, one of the creators of React. And he gave a talk in 2014 saying, okay, these are the 7 problems that we had with CSS, and we solved all of these problems with Inline Styles. So let's see, I guess you might have one of these problems in your life. The first one is global namespace. No matter if you use BAM, if you use nested select or whatever, you are polluting the global namespace every time you write CSS, and that's bad. It's bad in any languages. It's bad in CSS as well. It's also really hard to define dependencies between your components and the CSS. So, for example, if you have a button, you cannot easily say like this button depends on this, and this CSS. Dead code elimination is pretty hard. It's pretty scary because you never know what's going on if you delete one single line of your style. There are some tools that can spot like unused CSS and stuff, but it's always hard to know exactly what to delete without breaking the code base. Minification of class names in JavaScript, CSS, and HTML is hard as well. Sharing constant between your application and your CSS is not easy. I mean, you can do that even using different languages, but obviously if you use the same language, it's going to be easier. Non-deterministic resolution is a bigger problem, because if you load your CSS asynchronously, the order matters. So sometimes you don't know what's going on because you loaded a CSS before the other. So if you go in a section of a website and you load a CSS asynchronously, you can have some surprise. And isolation. No matter how good you are at writing CSS, but someone else can always override your style, and that's pretty bad. If you work on a button, someone else can override the style that you are applying to that button. So you are not sure what's going on, what is going to be the result. So they said we solved all of this problem with Inline Styles. So let's see what it means to write Inline Styles today. This is the only React-related slide, but yeah, it works like that in any other languages. Basically, you can do the same in Angular and whatever. When you write inline styles in JavaScript, you define an object literal where all the keys are the rules. In this case, you have to use the camel case. So, for example, background image is camel case. But the good thing is that you can use variable, and then you just assign this object to the style attribute of the element. That's it, and you render your component like this. There are some good things in using inline styles in this way. I tried it, and these are the things that I found pretty good. So the first thing is that you can recompute your style on the fly. So you can, for example, if you have an input element, you can set the font size of the input element according to the value of the input itself. So the value is 30, the font size is 30, something you cannot do with CSS, with static CSS. The fact that you use object literals is great because you have the full power of JavaScript. So you can use functions, variables, merge objects, whatever, and it's great. You can concatenate string, do crazy calculation, and that's great as well. The application state. When you write your application with inline styles, it's not about writing all the CSS with inline style because that's crazy. But you have to find which part of your application you have to write you could write with inline styles. Because, for example, grids, base fonts, base style, that they are okay if you write them with classic CSS. But for example, for the application side, so for example, if you show an error with JavaScript, the logic of showing and hiding the error is made with JavaScript. So you can do the same for the style. So the error is red. You put the color red inside your JavaScript with inline styles. So that's the thing. You are already basically handling the state with JavaScript. You just have to accept that the style is the state as well. And testing it becomes easy. You can test both the behavior and also the style. So if, for example, color red, you can test that an object with the color red has been applied to your element. Obviously, there are a lot of downsides, a lot, as always happen in computer science. Pseudo classes and pseudo elements don't work. Media query don't work as well, unless you do some weird tricks. Unless you apply, for example, instead of using hover, you listen to browser events and you apply and remove the style according to the JavaScript event, but that's pretty crazy. And you cannot have style fallbacks. So you are using a JavaScript object, so you cannot, for example, have the display attribute twice. So display flexbox and display webpage flexbox or whatever. Animations don't work. You have to always override the style using important. That's bad. It breaks the separation of concerns if you are used to have CSS separated from HTML, separated from JavaScript, because obviously you move your style into JavaScript. And performance is there with a question mark because I couldn't find a blog post or a benchmark that clearly says that performance are worse. But obviously, if you render on the server side a lot of elements with very long style string, the page is gonna be bigger. So there are no one can tell you is performance are worse, but they are. I mean, it's easy to think that they're gonna be worse. Debugging it's crazy. This is a real world example. So when you use inline styles, obviously you're gonna see something like this in your DevTools, and this is pretty hard to debug. First of all, it's hard to find the element that you want to if you want to change the style on the fly, something like that. It's really hard to find it because you usually use class names to find the element. And also, if you have a list and you change the style for one item, you're going to change the style only for that item, not for all of them. So that's very bad as well. So basically, inline styles are not the answer, I guess. Even at Facebook, they are not really using. Even if this guy says we solved all the problem with inline style, I don't know. In the Facebook website, they are not using inline style. They use inline style in React Native, which is a thing, but not on the web. So let's see if there are any other solution or different solution to solve the same problem in a better way. And the first one is Aphrodite. I choose a couple of libraries which are like the most, the newest one basically, and they are not related to React. So the first one is this one, and you basically import the style sheet object and the CSS function. You define an object as we saw before. So you define the style as a JavaScript object. So you have the full power of JavaScript. You can use variables, functions, whatever you want. And you create the style sheet like this. And then you assign the style you just created to the CSS function. And the good thing is that you can also use hover and media queries, because in the end, Aphrodite is inline styles that work. It's not inline styles. In the end, they render like classes, but they call it inline styles because you can co-locate the style with your component, and it's an object. The good features here are that you can use pseudo selector, you can use media query. Smart style injections means that if you have a very, very big object to define your style, and but you apply only one small piece of that style, they're going to inject on the page only the CSS that you are actually using, and that's pretty good. And the auto prefixer is included, which is also good because you cannot have like a pre-processing or post-processing. You have to have something in the browser. Another library is CSSX. It looks like this. It's a little bit different. It's very smart. You create a new. You basically define a style sheet, but on the JavaScript in completely differently from inline styles or whatever. You basically create a new sheet like that, and you add all the classes that you want. So, for example, here we are adding the button, and we say the button is going to be red. And you can also update the class you created with another color, for example. So the result of this is going to be a CSS injected in the head of your page with the color green. And this is great because obviously you don't use it like this. You update maybe the color according to some events or something that happened on the page. And if you are very brave, you can use a syntax like this, which is like HTML, CSS, and JavaScript all together. It's basically JSX for CSS. It's a transpiler, and this is good. In this case, you cannot use obviously. I mean, you can use JavaScript function if you concatenate the strings and stuff. But yeah, if you want to use the full power of JavaScript, you can use object literals like this to define your styles. CSSX is just a set of tools to write CSS in JavaScript, obviously, and it comes as a gulp task, post CSS plugin, CLI, a transpiler, so you can use it in any project, and it's the benefits of it are avoid additional state classes. So instead of adding, for example, you usually have classes like is error, is active, is warning, is something. You can remove all of that classes because with the CSSX you change the CSS. You don't add and remove classes to the DOM element, so you don't touch the actual DOM element, but you update the CSS. So the CSS, you apply just the button class, but the button class before had the color red, and then when you click, the color becomes green in the CSS, so you don't touch the DOM element, and it's real dynamic CSS because you change the CSS on the fly. With both library, you can export. Obviously, they are not dynamic anymore, but you can even export the CSS at build time. So you can have a base CSS exported and put in this CDN or whatever. The last library, and my favorite one, is CSS Module. You already had the talk here, but I'm gonna tell you very, very few things. With CSS Modules, it's basically real CSS. So you define them in a CSS files. And you define, for example, the common class, and you say the color is red. Then you import your CSS, and you apply the class to the element. That's it. The result of this is going to be something like this. CSS Modules, by default, create a hash of the of the class name, so they are scoped locally to the element where you imported them. And in fact, they start from a very, very simple point. They started with Webpack. You could import the CSS as any other dependency. So they thought, okay, we can scope all the class and animations locally. So basically, you avoid the clashes in big code base. That's good. And also, it's really, as you can see, it's really clear how to define dependencies. So you see, okay, this button depends on that CSS. That's it. You're sure about that. And there is also one very cool feature. You will see how we are using it later. So there is composition. So you have a class, which is class name, color green, background red, and you have another class name, and the second one composes the first one. And composite doesn't work as extend, where you would have other class name declaring the same style. But when you apply the other class name, your CSS module is are gonna add in the two classes to your element. So if in one of your elements you use other class name, you're gonna have other class name and class name as well. And if you compose it 100 classes, you're gonna have 100 different classes. So your CSS don't change. What changes is the result on the browser. Using it with Webpack is very easy. You just add a new loader, but there is also a plugin for Browserify. And the coolest thing you can do is that you can decide how do you want the CSS to be compiled or hashed. By default, they are hashed. This is the site of Gladmother, which is one of the creators of CSS modules, and he using emoji. This is great. I mean, this is a reason to use it. And okay, almost finished. We had to start at Whiteplan a project a few months ago, and we wanted to use CSS module. But then I came here to Frontend London, and Richard Bray gave a talk about atomic CSS. Atomic CSS looks like this. You define very small classes where every class has only one single rule. So, for example, MB0 is margin bottom 0. So you define all the classes you want, and then you use all of them in the element. As soon as I seen this, I said, okay, no, that's completely wrong, I'm not gonna use it. But I seen a lot of smart people here at FEL saying, oh no, it's good, why I'm gonna use it. So I wanted to see why, and I went a little bit deep I dig into the problem a little bit deeply, and I found out that there are bad parts and good parts. Obviously, the bad parts are that there are too many classes. I mean, if you have an element with 20 classes, it's really hard to say what's going on, like predict which will be the style of that element. It's very similar to Inline Styles. A lot of people can complain, okay, you are using like a shortcut like MB0, but basically you are assigning style with the class names. And it's very hard to maintain because you are moving all the style logic from the CSS to the HTML basically. So when you have to change the style, you change the HTML, which is pretty bad. But we also found out that there are cool things. For example, quick prototyping is very as soon as you have all your classes defined, so MB0, MB1, MB2, whatever, or if you use some libraries that there are already out there, it's super fast for prototyping pages. And the file size of the CSS, and that's the greatest thing, is it remains the same. Because whenever you create the base CSS, so you define all the classes that you want to use in your code base, whenever you add a new button, a new section, a new card, a new header, you are just composing those classes. So the CSS file is not going to grow. And that's great. So we said, okay, how can we solve the bad parts and just have like the benefits? So we are using, and we are trying, I'm not saying it's the right solution, we are using atomic CSS modules. So basically we are using CSS modules to compose the classes. So we keep the style on the CSS and we let the CSS module to do the bad job of adding like 20 classes to the HTML. And yeah, it's working. We had a couple of problems. The first one is that you cannot compose on pseudo elements, for example. So if you have title hover, you cannot use composes. But we are writing a post CSS plugin for that. And another problem is with the order of the import. So if you import fonts and margin in this order in this file, and in another file you change the order for some reason, the compiler is going to complain. So there are still some problems, but I wanted to tell you this is a good thing. I mean, you can try it. It's funny. The end. Recap. Use the right tool, no matter if it breaks the rule. Don't start saying, I'm using SAS, I'm okay, I don't want to change. Try it. I mean, it's really, really hard in the beginning because you are basically doing something that you learned that it goes wrong. So first you have to accept that, and then you can do it. And inline style versus local scope. So inline style are here, CSS modules are here, and in between you have Aphrodite, CSSX. You have a lot of library range. If you use React, there are a lot of, like 32 libraries. If you don't use React, maybe 10, 15, but they are enough to have fun. And appearance versus state, you have to choose really careful what do you want to handle with plain old CSS. So, for example, grids, layouts, base styles, and what you want to handle with JavaScript. So, for example, everything related to the state should be JavaScript because you are already handling the state in JavaScript. You are just using classes as proxies, but the state is managed by JavaScript. And most important, have fun, because when I talk with people about CSS in JavaScript, a lot of people get angry. Oh, you are saying something that's really bad. So no, there are a lot of libraries out there. Have fun, and that's